a topic called polarization. So this one is essentially just for your estimates topic, where you need to know average values of wavelengths. So these are the values you need to know. Okay. So radio is anything more than 1. Micro is in the range of a millimeter or a micrometer. Infrared is 1000 nanometer. Visible light is important. Okay. From 700 to 400. Which one is high, which one is low? That's very important. Okay, so এটা মনে রাখতে হবে, and rest is ওরকম আসে না, তাও জেনে রাখা better. And also, more importantly, you need to know how does it change, like how does the wavelength vary, how does the frequency vary. I'm hoping you know the similarities between them. They all travel at the speed of light. They all are transverse waves. They all transfer energy. They do not need medium to travel through. But এই পেজে দেওয়া আছে, okay. Are you guys done? Okay, সবাই screen to let's start this thing. আগে থেকে heads up দিয়ে রাখি, complicated, okay? Because not because it's actually complicated, because you don't really have any study material. তোমাদের হচ্ছে it was added last year, so we only have 2 questions and they're pretty challenging, okay? So I'm assuming it's going to be difficult questions only from this topic, okay? Easy করা যায়, but easy to দেয়নি so far. So let's see what this is. So today we're going to learn, first of all, what is the feature of an electromagnetic wave. An electromagnetic wave জিনিসটা কি? Because it has a very strange property. It doesn't require what to travel through, medium, right? So the way we learn waves, it's all about medium, like things oscillating as the energy goes through it. Water molecules are moving. When you have your string or anything, when you have waves, particles moving, right? But what is this electromagnetic wave where you don't have a medium? So what is that moving to it? So when something is passing through space, right, and it's an electromagnetic wave, what is actually oscillating out there? So it turns out it is it says here it's electromagnetic, right? So it's actually the oscillation of an electric field and magnetic field. Turns out এই field গুলো space এর মধ্যে exist করে, and এগুলো যখন oscillate করে, you have an electromagnetic wave. Okay, so I'm going to show you how it looks like diagram draw. So typical electromagnetic waves will look like this. So you have 3D diagram here. Okay, this is your typical wave, and what I'm drawing right now is the electric field unit. And I don't know if you will be able to get out if I show what's up here. This red part is the magnetic field. So how is this really? Now so this blue part that you see here, it's like the upright vertical plane. Think of it as a plane, like a sheet. Okay. And this red part that you see here, it's a flat downwards horizontal, and the angle between this plane, this is the plane of oscillation, and the plane here, plane of oscillation, is how much? 90. I have a picture for what's happening here. So this is what the planes look like. So in an electromagnetic wave, you have a vertical plane that goes up and down. You have a horizontal plane that goes left and right. Okay, so the horizontal plane, as you can see here, is going like that, the red one, and the vertical plane is going up and down. And turns out the interaction of these two planes is what results in your wave. So why are these two planes resulting in my wave? So this is my electric field and this is my magnetic field. We'll go back to all of those a little bit. Do you remember the Fleming's left-hand rule? Right. So can you use Fleming's left-hand rule here and tell me which way is force being exerted? The electric field is the current and the magnetic field is the magnetic field, right? So tell me which way is the force being exerted. Electric field is the direction of the current. Magnetic field is the direction of the magnetic field. So if you apply that here, which way is the force acting? Towards right or left? That way. What about everyone else? Point for it. Yep, it's in the direction of the arrow. F, B, I, right? Current is which way? Electric field upwards. Which way is a magnetic field? The magnetic field is towards out of the screen, if you could say, which was my thumb pointing the force to the left, right? So we don't have this in our syllabus, but this is the origin of the force. So what's happening here is when these two interact, right? What does the system experience? A force. And that force is what pushes the energy forwards, and the energy comes from it. So basically, duita field crisscross each other continuously, and the crisscrossing generates a what on the system? Force, and it propagates it forward. It could be, I would say, weak analogy as it, but it's an analogy. Think of a very small table tennis ball, and you have two paper in your hand, right? And you move the paper behind the ball. Which way does the ball start to move? Like, you're fanning the ball. Cardboard niye, just you're crisscrossing them like that, right? And samne ka ball runs. Ball ta kon dike jabe? Soja je thakbe, and you keep pushing it like that. So you're basically pushing the energy forward by manipulating the field around it. It's very complicated physics. We do not have entirety of it. We have only one part of it that we need to learn for our A levels, which is electric field and magnetic field are in two different what? Planes. Planes surfaces, right? Which means the most important part, electromagnetic waves consist in what? Multiple planes. They're not linear. That's the thing we need to understand. But originally, everyone used to picture waves as what? A line. And it is like that mostly, right? But electromagnetic waves are different. They're actually a combination of what? An up and down plane and a left and right horizontal plane. And এই দুইটা যখন actually interact করে, right? What does that generate on your system? A force, right? And that is what electromagnetic waves are. So if you want to draw an electromagnetic wave, what I have drawn here is the most basic version of it. মানে হচ্ছে এর চেয়ে basic possible না, because I have drawn a single wave, a single possible wave. That's the diagram. What you're seeing here is a single electromagnetic wave out there. But turns out this is like not what typically they look like. Typically they look something like this. It's our version. তোমরা কি 3D nature টা বুঝছো? That it's in multiple planes, like X plane and Y plane, right? So the 3D nature of this means that when you see a typical light, and if you want to observe this light in, like, you know how it is, right? এটা এরকম দেখতে না, মানে যেটা আমি draw করলাম, it's much more complicated. I'll tell you why. It consists of, and I won't be able to draw this unfortunately, but I'll try my best. It consists of thousands of such combinations. So what you see here is one set of combination. Etar perpendicularly arcta set with away. Otherwise this doesn't work, right? So you have another set of oscillation that's happening in this direction. Etao horizontal plane back and forth oscillate korbe. So something like that. And you are expected to draw this, but thankfully they have given us another option. But the point I'm trying to make here is the waves are in what direction? Every possible imaginable plane out there. So it's not just x, y, it's every angle out there. So এগুলো যদি সব combine করো, you see the wave that you normally see as electromagnetic waves. So my question for you, electromagnetic waves exist in what planes? Every possible plane, every possible angle. Okay, imagine any angle out there, you have an oscillation of plane, right? And the more the planes are, the more the what would be the intensity of your light. So when you look at a light and it's very bright, what does it send in you? Many planes of oscillation. If you're seeing a light that's dimmer, what does that mean? The planes are limited. Okay, so এই জিনিসটা I understand students struggle drawing it, which is completely fine. আমরা যেটা করবো এটাকে একটু revamp করবো to make it easy for you guys. Okay, so আমি আরেকটা প্লেন দিয়ে রাখি. So exam-এ what are you supposed to draw? ওইটা দেখাবো এখন. এটাই draw করতে হবে, but কেমনে draw করে দেখাবা? So luckily for us, we will not be drawing this anymore. This is the last time I'll be drawing this as well. এটাকে কেমনে draw করতে হয়? We draw it from the cross section. So you look at the wave coming to you, not at an angle. Okay, because it looks like scribble if you look at that, right? So it doesn't really have a pattern to recognize. But when you look up front, কি দেখা যাবে? So when you look up front, you'll see that there's a green line that goes which way? Up and down. বুঝছো কোনটা? এই যে এই গ্রিনটা খালি up and down যাচ্ছে না এদিকে? Do you see the red that's going sideways? So redটা ধরো এই যে এখানে যদি redটা draw করি আমি, it looks something like this. That's the plane of oscillation of the red one, right? Then what else do we have? A blue line which goes something like that. Then we have a purple line which goes something like that. So if you eventually draw all the planes out there on an electromagnetic wave, you'll find that সামনের থেকে দেখতে it's much more easier. Do you understand what are we looking at right now? So each of these lines that you're seeing from the front, right, are actually waves oscillating up and down, left and right at different angles. And when they all combine, what do we get? An electromagnetic wave. And more the number of lines, higher the what of your wave? Intensity. Okay, so এটার সাথে যদি compare করি এটা, let's say this one here, sorry. Yep, so এটা যদি compare করি, this one is a much higher intensity wave out there because there are more number of planes of oscillation out there. Okay, but here's a catch. Whenever we draw this diagram, we only draw the electric plane. I will repeat for you, this is a point of confusion. Whenever we draw this diagram, we only draw the electric plane. And with every electric plane, there must be a what plane as well, magnetic plane, or the draw kara hoy na. And the reason behind that is simple. If I drew all the fields out there, electric and magnetic, right, how many lines would I have? Double the number. Do you understand why? Because আমার প্রত্যেকটা ইলেকট্রিকের সাথে একটা perpendicular কি থাকতে হবে, magnetic field. So imagine all of the lines that you see here, all the lines that you see here, they have a pair of what line with them as well? Horizontal magnetic field. আচ্ছা, ওটা আমরা draw করি না, ওটা draw করলে কোনো added advantage নাই. Okay, we'll see that soon কেন. So these are all representation of what planes? Electric. Okay, and this is front view. Exam যদি তোমাদেরকে electromagnetic wave draw করতে বলে, you draw this view. Okay, this is low intensity, this is high intensity. So yeah, that is what your electromagnetic waves are. কোনো question থাকলে আমাকে বলতে পারো এখানে. This is the 3D view. They will not ask that, don't worry. And one very important point that you need to keep in mind is that electric field and magnetic field must be what to each other? Right, magnetic field must be perpendicular to each other. Where do they originate from? Just general question. কোথা থেকে আসে field গুলো? এই light আসতেছে আমার কাছে. What's happening there that it produces a field? I feel like you might have heard of this in chemistry though, but physics we have it later on because it's one of the most advanced branches of physics. Why is there light? That's the question. Light cannot. Light cannot hoy. The answer is only one particular way. Light can only be generated in one particular manner. What is that? Where? Yeah, I mean, you and online education got it right. It's the transition of electrons. একটা atomer মধ্যে shells থাকে, shellের মধ্যে electrons থাকে. Electrons যখন up and down move করে within the shell, right? They give off energy, and the energy exclusively comes out in the form of what? Light. And chemistry তে কেন শেখানো হয়? Flame test. So there's something called flame test. So flame test when you place the iron on a flame, electrons superiorize for it. Electrons যখন fall for it, they give off certain colors. And that's the colors of the flame test. Okay, physics we have it. It's called quantum mechanics. We have it in A2. Okay, right. So copy whatever you want from here, and then I will move on to the next part. So Tajik Guru. ওই যখন হচ্ছে তোমার শেলের মাঝখানে ইলেকট্রন গুলো ট্রানজিট করে, electrons have an electric field, and as they move between the shell, moving charges produce a magnetic field. So ওরা যখন মানে ট্রানজিট করে, they release that plane, and that's where the field comes from the sun, from the lamp, everywhere as the electron transit, they generate a field. It's like ripples in a wave or water or a book. Just give me a second. I'm going to chat for some add for it. This is not our topic though, surprisingly. It's something we need to know to start our topic. So on the topic because our topic's name is called polarization. Okay, so you need to know what an electromagnetic wave looks like in order to understand polarization. Done, everyone? পুরোটা ড্র করা স্টার্ট করুন, তাহলে ক্লাস শেষ হয়ে যাবে। Just you know, whatever you can have as a reference ওটা লিখে রাখো। I personally feel like it's enough. This one here, these front views for what I'm going to do right now. What I don't need to get enough. Okay, questions online কিছু আছে নাকি দেখি। Both make up an electromagnetic wave together, right? The electric field and the magnetic field together has to be the electromagnetic wave. What if you have just an electric field? It's not a wave. It's not a electromagnetic wave, okay? Or just magnetic field. Yes, these are also known as unpolarized light, which এখন আমরা দেখবো। Second diagram again. Second diagram তো হচ্ছে এটাতে যেমন I just drew two lines, right? ধরো blueটা আর redটা, but আরো অনেক different angles এ oscillation হতে পারে। So ওইটা হচ্ছে second diagramটা show করতে যাচ্ছে। How do we know which one is the electric plane? by the label. Label not say anything, right? So label থাকতে হবে. Yeah, it's going to be labeled. What causes intensity to be high because of the line? Imagine each line as a wave. So when you have multiple waves, wouldn't it be brighter? So that's how the intensity is working. Acha, so I think I need to move on. Before I go on. To clear, yeah. So essentially, what you're seeing here is how an electromagnetic wave looks like. I have reduced the resolution because I want it to be smoother. So the green ones that you see here are one of the fields, and the red ones are the other. Okay, I'll make it easy for you guys to understand. Yeah. Do you see right now the green lines? So it a কোন plane oscillate হচ্ছে, the X plane or the Y plane? Y plane, right? Vertically upwards. And this one is sorry. Yeah. And this one is oscillating along which plane? X plane, horizontal. So when the X plane and the Y plane interact together, that's when you have a wave. And that's the wave moving forwards. Do you understand? So the wave that's basically the interaction of those. Now, if you struggle viewing the planes, that is the vertical plane, that is the horizontal plane, and what are they to each other? Perpendicular, okay? And that's when you have the wave generated. Clear? So that's just one wave, by the way. Getting to one wave, duita mile, okay? Right, so let's see what our chapter has for us. So we will now move on to the next page. Or can I actually continue, Kori? The chapter or the topic that our syllabus wants us to know is called polarization. Under S, the polarization. Okay, সবাই screen let me show you কি হচ্ছে এখানে. Do not write anything. It's a very short topic, but it's absolutely new for you. Okay, so see what's happening here. So we are going to draw an electromagnetic wave right now. So can you tell me what do I do here? I have drawn a line here. Can you tell me what this line represents? Huh? No. It's front view of what? Electric wave. No. Acha. Correct. Okay. It is the electromagnetic wave just showing which field here? Electric. Always remember this. আমি যখন draw করবো, I will always be drawing which field? Electric field. Okay. So that's just one wave we're looking at. The confusion here is students might wonder, shouldn't there be another one out there? And yes, you're right. There should be another one out there. What is that supposed to be? A magnetic field, right? But to keep our diagram simple, right, we ignored that. And you'll see eventually why we ignore it. So that's one wave, but I want many waves out there. So can you tell me what can I do? Yeah, increase this number of planes out there. So also a heads up there before we get into polarization. Electric field and magnetic fields are fields and they have direction, which means they are what? Vectors, which means what can you do to them? Something that you guys don't like. Break them into components. Okay, so it's possible. Anyways, they can be broken down into components. Okay, so we'll have to do that eventually at one point. So yeah, you're looking at a wave here that has a lot of electric fields out there, and this is very high intensity, and you're looking from the front. Yes. Fields will have Barrett strength. So as the electron moves, the strength of the field fluctuates, and that fluctuation causes the wave to form. Just like a constant field, they have to change. Okay, Right, so this is the electric field. Let's write down a few things about this. This is the diagram of a front view of a what wave? Electromagnetic wave. So front view electromagnetic wave showing what only? Electric fields only. Clear? Okay, now look at this. Screen HOI. This is the start of polarization. What we're going to do right now is place a filter in front of this. A filter গুলোকে বলা হয় polarizing filters. Sometimes they're also called Polaroid filters, right? Different from Polaroid camera films, sort of different. They just stole the name. So this is a polarizing filter. What is this actually? It's actually made up of this material that has a chemical coating on it, right? That can block electric fields. I will repeat, the material has the ability to block electric fields. It cannot block which field though? Magnetic field. Are you with me so far? So a material it's like camera films. Have you seen them into brown color, silver coated thake? Or it's actually very similar to that. But the thing that's unique about this is that in this particular film, microscopic level, okay, like really, really small, nanometer level, we have these gaps. Gaps গুলো খুবই precisely align করা এরকম দেখতে. There used to be only 2 components in the world that used to make these. এখন a lot of people make them. So we filter গুলো খুবই precisely করা. So there are very small gaps in them, and these are the gaps, okay? And the filter that you're looking at, the lines I've drawn, are made up of a material that can block what? Electric field. Are you with me so far? Acha. Can you tell me if this wave, right, the one that I've drawn here, tries to pass through this, right? Which plane will be perfectly allowed to pass through? Yeah, the vertical one. মানে যে এটা perfectly কিন্তু চলে যাবে, কোনো প্রবলেম হবে না, because এটা তোমার হচ্ছে গ্যাপের সাথে fully match করে. মানে the gaps are designed in such a way that it allow করবে. এটা সবাই বুঝে. Now, what about the others? Do you think the others will be able to pass through the other lines that I've drawn? Yes, they won't be able to, but their what will be able to? Components. So let me give you an example. So আমার যদি এই ফিল্ডটা হচ্ছে এরকম দেখতে হয়, এটা কোথায় থাকে এখানে? So একটা ফিল্ড ধরে এরকম দেখতে হয়, wouldn't I be able to break it down into components, right? What would the components be? এখানে যদি অ্যাঙ্গেল থাকে theta, right? What would the components be? There will be a vertical component, right? এদিকে একটা vertical থাকবে. Can you tell me what would the vertical component notation be? এটা যদি E হয়, is sin theta or cos theta? Vertical to sin theta. So E sin theta. So this E sin theta will be able to pass through. My question for you is, as the theta decreases, does more of it pass through or less of it pass through? As the theta decreases, বেশি pass করে না কম pass করে? কম. কারণ একটা vertical line কে তুমি যদি components এর breakdown করতে থাকো, right? The angle যত কম হয় এদিকে, এটা বেড়ে যাচ্ছে, but এটা কমে যাচ্ছে না. Like think of sin 0. What is it? 0. Or sin 1 a very small number. When is sin the highest? Sin highest value কখন হয়? 90 তে. So 90 যদি থাকে, all of it passes through. Any number hereafter will start to get lower and lower and lower. And when it's like that, what is it? Completely blocked, right? So in this case, what will happen is multiple components will be able to pass through. So এখানে অনেক components pass হবে. And আমি just এখানে কিছু color দিয়ে রাখতেছি বোঝানোর জন্য that বাকিগুলো fully block হয় না, বাকিগুলোর কি block হয়? Certain parts of it, right? So you still have some of the wave passing through, right? So again, one more time question for you. I have the unpolarized light. By the way, এটাকে বলা হচ্ছিল unpolarized light. ওটা পরে explain করতেছি. I take this light, I allow it to pass through a polarizing filter, right? And only one particular plane is allowed to pass through, and rest of them are getting what? Blocked, right? Once this comes to the other side, question for you guys, okay? Will it be the same brightness as the original light, or will it be less in brightness? Lower in brightness? Definitely lower, right? Because aren't you blocking out way many planes out there? Some of it will pass through, right? However, তোমাদের সিলেবাসের মধ্যে এটা ডেরিভেশনটা নাই, but ইনফরমেশনটা জানতে হবে. If your original intensity was I naught, A polarization filter will always make the intensity I naught by 2. There's a mathematical reason behind this, which you don't have, so I don't think it's going to bother. I'll give you explanation as we do some questions. So it always becomes half of it. Whatever the scenario is, half of it. And it's to do with components, actually. We'll see that later, okay? So this light that we have here is called a plane polarized light. What does it mean by plane polarized? Plane polarized the light consists how many planes? Yes, that's it. It's as simple as that. Plane polarized light consists of a single plane of oscillation. Here. Now my question is, what is the magnetic field? Yeah, that's simple. It's not electric, right? So it passes. So the thing is, what we need to focus on in order to understand if they pass or not is the electric field. The magnetic field is not a consequence here of any manner. So magnetic field is not going to occur. You get my point. You may draw the really help our answer because it doesn't really get blocked by the filter. What is the one that gets blocked by the filter? The electric. That's why we know the electric. Clear about that. So yes, this is the plane polarized light. Definition of electricity for it. Our right side is the load, or left side is the unpolarized light. It is part of the light. And without the magnetic field, you won't have the light. The interaction of the magnetic field and the electric field generates an energy. That energy is the wave energy. Just an electric field doesn't generate the energy. Electric fields do have an energy. It's called the electric potential energy. Magnetic fields also have an energy, but these two need to combine to send your energy forward in form of light. And in quantum mechanics, we learn it's called a photon. It's a particle of light that's been pushed forward. So if pushed forward, you need magnetic field and electric field interacting. Okay. Oh, that's true. That's possible. I read recently that they made polarizing filters that are capable of blocking magnetic field only, not electric field. What do you think would be different? Exactly. It'll be just the same thing, but this time, what do we rely on? Yeah, exactly. Okay. So eventually, এখানে কোনটা কি matter করে না, just একটু উপরে focus করলেই হয়. Right. So that is your plane polarization. এখানে answer আছে একটা copy করতে হবে. But yeah, more importantly, if you have any questions, do we have circularly polarized light in our syllabus? No, we do not talk about that. They're complicated only. Our question ছিল হচ্ছে, why do we need this polarized sheet to get polarizing light? What's the purpose? That's a very good question. Unfortunately, our syllabus doesn't really teach that, but I'll teach you because খুবই helpful একটা জিনিস. Why do we do this? What's the need for this? Random একটা জিনিস শেখার তো কোনো মানে নেই, right? এটা খুবই helpful. Huh? Yes. So at this particular moment, we all are using polarizing filters. You are not aware of it. কোথায়? Sunglass কে পরে নাই। কোথায়? TV screens. All screens that's out there, they're all polarizing filters out there. Phone screens, there are polarizing filters on top of them. Sunglasses, camera lenses, whatever you can imagine that's based on optics, right? Uses polarizing filters. It's very helpful. 3D glasses that you use in the movies, they're polarizing filters as well. এখানে যা আছে একটু কপি করো, এগুলা সব ইম্পর্টেন্ট, ওকে? in fact, a exact diagram to the diagram. They'll ask you a question or they'll say, using a diagram, show how plane polarization takes place. And that's the diagram. Polarizing sunglass keeper. I'll explain. There's something it does. There's a question: why are the blue and red arrows shorter than the black one? Key reason. Yeah, because their components are passing through, and the components are obviously less in magnitude. Are you guys done? So there's a definition of this. একটু বাসায় কপি করে নিও, I'll upload that today. ওটা আজকে রাতে কনফার্ম করবো টাইমিং। That means magnetic field always passes through the polarizer, correct? In this version, yes. তোমাদের তো Thursday off, right? Thursday, school's closed. Okay, let's move on. শেষ না সবার? Okay, এটা দেখেনি because I want to wrap this up by this week. Online class আগলা মিলে, so এটা যদি দেখা রাখতে পারি তাহলে শেষ হয়ে যাবে। সবাই একটু স্ক্রিনে, let me explain what's going on here. So we have this light that has been plane polarized. Okay, তোমরা কি দেখে বুঝতে পারছো it's been plane polarized? Which plane was allowed to pass through? The blue one, right? And the rest of them are blocked out. Do you understand? So if somebody looked at this light from this side, right, what would you notice? In terms of আমরা যখন light দেখি আমরা তো planes দেখি না, কি দেখি? Intensity, right? So yeah, a lot of you said you'll see straight line. That's not true. Would you see a straight line? Not what would you see? Yes, you'll see light that is dimmer. That's the right term. Just so you'll notice that there's a drop in intensity. So if I take a Polaroid filter right now, I'll bring my own next class. So if I hold it in front of the screen, you'll notice the screen is now what? Dimmer. Cannot? Because a lot of planes got blocked out, right? But did all planes get blocked out? No, right? Okay. Now what we can do is block all the planes. So it's a key code. I want to block everything. I just don't want to see light. Key code using polarizing filters. Yes, exactly. So place another polarizing filter in front of the one that you already did. But this time, make sure that the polarizing filter is what to the original one? Perpendicular. And if you do that, you notice that light entirely blocked. Why is that so? Yeah, because only the one that is available is what to this plane? Perpendicular, tell block ho jabe na. What I'm trying to say is that we only have one plane coming through right now, right? And now if you place something that's perpendicular to that, wouldn't that get blocked out? So nothing passes through. And you'll place your eye here and you'll notice what? Darkness, proper darkness, okay? So এটা আমি তোমাকে এখন একটা example দিয়ে করে দেখাই. So এখানে you will not really see any light. What would you see in between? A bit of dim light. And what would you see at the start? Bright light. A sequence is very important. You'll first see high intensity here, then you'll see half intensity there. And what would you see at the end if you place it perpendicular? Darkness, right? This is actually a confirmation that your light has been what? Plane polarized. So my TV screen is actually plane polarized light. Achha, how can I confirm? I'll take a Polaroid filter in front of it. I'll place it there. Right? And then what do you do with that filter? Rotate it. As you start rotating it, at one particular point, you'll notice what is the light that's coming through? Zero. And what does that confirm? Plane polarization. Sure. I mean, the animation করে দেখাই তোমাদেরকে তাহলে easier হবে. To screen দেখো, these watches also generally have polarizing screen, okay? যেগুলো backlight থাকে. So what I'm doing right now is I'm taking a polarizing filter, right? And I will place my polarizing filter on top of the watch here. As I place it on top of the watch, what did the screen become? Dimmer, right? What does that tell me? That some planes were blocked, right? But how do I confirm that it's not just blocking the light for the first time, but it's rather blocking plane polarized light? But how do I confirm the light was plane polarized? So I'll rotate this. See what happens. As I rotate this and I go like that, at one particular point, the screen is full brightness. What does that mean? That my filter and the screen's waves are what to each other? Parallel. But now if I rotate this further, I start to notice something. And you'll notice that as well. What is the screen becoming? Dimmer and dimmer. Why is it getting dimmer? Because only components are now allowed to pass through, barely. And once I take my plane and filter and make it like that, do you see anything? Barely, right? What does that mean? that the light that was coming from the screen was plane polarized. It had a particular plane, and my filter is what to that plane? It's perpendicular. That's like completely blocked out. So this is a confirmation of whether your source is plane polarized or not. Can you tell me what if I took a filter, place it in front of the light, and I kept rotating it, but I never saw a change in brightness? What does that mean? When I যাই করি দেখি same brightness আসে, dimmer আসে তো. It's like dimmer than before, but at every angle it's the same brightness, same low brightness. Has. Yeah, so basically you're just seeing the first polarization. First polarization, যখনই যে কোনো angle এ নিয়ে যাবো, wouldn't some plane always pass through, right? But second এর মধ্যে কিন্তু there's only one plane available. So ওইটাকে তুমি যদি 90 ডিগ্রিতে নিয়ে যাও, what happens? It gets blocked. Are you with me? কি হচ্ছে? আচ্ছা. Right, so that's the confirmation for plane polarization. It's an experiment. Eta, what? In the what? The bug or something. It's not supposed to be visible.